The idea of this is data center in a rack system architecture. So all of the data center power and cooling infrastructure needed in a data center are included in the same system, including the compute, the storage, and the network fabric. And also the power distribution and the cooling distributions. Very high bandwidth, very high performance capability, very high density and manageability across these whole systems. The Power 775 is a very compute-intensive, large-scale system focused at the large-scale data center, supercomputing, high-performance computing systems. The system itself is housed in a new form factor of rack. It's a meter-wide rack and 7 feet high. What's in the rack, I'll start from the bottom, is the integrated cooling with water pumps and heat exchangers. All of the heat in the rack is transferred directly to the building chilled water, so there's no thermal load on the room. On the power distribution, it has integrated power regulation, control, and distribution. We have integrated storage, so up to hundreds of disk drives in the rack, either hard spinning or solid state. But the core of the system is these server drawers. Each one of them has 256 Power 7 cores per drawer, and we can have up to 12 drawers per rack. But the real focus of this is data management, being able to work through and operate and analyze large amounts of data in the drawers and across drawers. This is the cluster interconnect, give an idea of the density of the bandwidth across the systems that ties these drawers together. This is the compute node. It's a drawer that's a meter wide and 1.5 meters deep. The chip is 8 cores per chip and 4 floating point units in each of the cores, so we get 2 flops per cycle for each one of the floating point units. This is a closer up view of the drawer. Again, the processors, lots and lots of memory. You appreciate how many DIMMs there are. There's 64 DIMMs across there. Each of these is a double high, double wide DIMM. We can support up to 2 terabytes per node with the 16 gigabyte DIMMs. The back is the power supply, and what you see in the front here is the network, the cluster fabric that ties them all together. This is what it looks like logically as far as the layout goes. Each one of these blue rectangles here is one 32-way server that would normally be a 4U or an 8U high server. It's all stored in the space of 4 inches by 4 inches by about 32 inches this way. So this is 8 large, powerful, high memory bandwidth, high memory capacity servers, all stored within one 2U high drawer. One of the big things is key is this globally addressable shared memory data structure, so you can get access to the data in memory that's in all of the nodes across the whole system directly with Loadstore operations. So it's a global addressable shared memory between all of the drawers. And you get more memory bandwidth, more SMP bandwidth, more fabric bandwidth, and better latency, all within the single rack. Just essentially, there's 3 components in the whole system. It has the processor chip on its hub, 4 chips per module. The hub chip, which is the interconnect, which also has its module with optics, and then the memory DIMMs that you saw in the drawers before. The focus of this in a commercial data center world is to really make it useful computing capacity. The key of this, though, is the memory here, which is the access to the data between the systems. We have within the chip, we have dual integrated DDR3 controllers with large scheduling windows, very high-speed channels to get lots of access to lots of the memory. And this is the DRAM modules. Each one of them has 40 sites on the front and another 40 sites on the back of DDR3 access, which would not be possible if we didn't have very low power, efficient memory chips. We very much appreciate the work that Samsung has done in making this available for us in this system, and it's a key part of what makes the whole system work.